Okay, for this chapter, we are going to discuss the protocols and models. That's part of our CLO1. We will discuss and learn about the roles and communication fundamentals, protocols and services, network models, okay, and the OSI and TCP IP models, and so on. Data encapsulation as well, and local addressing. We will watch the video at the end of the session. As we studied last time, networks can be different size. We can have LAN, we can have WAN, CAN, and MAN, and PAN. There are three elements to any communication. You should have a sender or message source, such as people, electronic devices, they need to send a message. You should have a receiver or message destination, and then you should have the channel, how you will send the message. This consists of the media that provides the pathway over which the message travels from the source or the sender to the receiver. So these sender and receiver, they should be using the same, they should agree on the protocol, how they will communicate with each other. Okay, so we call this network protocol. So the requirements for this network protocol, the common computer protocols must be in agreement and include the following requirement. Any network protocol should have these things. Should have encoding or message encoding, should have the message format and encapsulation, also the message size, timing, and the message delivery options. We are going to log in to Net Academy at the end of the class, inshallah. As I just mentioned, network protocol is very important for our network. The network protocol defines a common set of rules. These rules are implemented whether in software, hardware, or on both. And each protocol have its own function, format, and rules. For example, for network communication by itself, it enables two or more devices to communicate, as I mentioned last time. So this is what is the function of computer network communication. Network security, to secure the data, to provide the authentication, integrity, and encryption, CIA. Routing enables routers to exchange route information or route information, compare path information, and select the best efficient path. Service discovery is used for automatic detection of devices or services. These are all functions of a network protocol. The devices use agreed upon protocols to communicate. So they have to agree on which protocol to communicate with. And protocols may have one or more functions. One important function of protocol is addressing. It will give an address or identify the sender and the receiver. It should take care of reliability or handle reliability. It should take care of flow control, sequencing, okay, which is adding labels, error detection to determine if data became corrupted, application interface. It process-to-process communication between network applications. So for the network protocol functions, the networks require the use of several protocols. And each protocol has its own function and format. For example, I have the HTTP. We all know the HTTP. We have also the TCP, Transmission Control Protocol. It manages the individual conversation, manages flow control also. We have also Internet IP. It delivers messages globally from the sender to the receiver. We have the Ethernet, delivers messages from one NIC card to another NIC on the same Ethernet local area network, on the LAN. Why we need network models? Because we said organizations, users, they need to communicate with each other. And if I have organization, I need to communicate with my also colleagues. And there is no guarantee that all organizations use the same equipment, hardware and software. So I should have some standard. If systems utilized proprietary software and protocols, then this would only allow communication between their devices. If everything is proprietary meaning what? It will only work on their device. And if I have a IBM proprietary protocol and only works on the IBM hardware, then it will not work on another device. So I should have some standards. So the solution is to create a standard. As an example, we have the TCP/IP standard or TCP/IP protocol. The TCP/IP operates at the application, transport, and internet layers. And we have also the most common network access layer or LAN protocols are Ethernet and wireless LAN. Okay, so these are two examples for TCP/IP protocols. It is effective at the application, transport, internet, and network access layer. Okay, application, transport, internet, and network access. Application, HTTP, transport, TCP, internet, IP, network access. The protocol is Ethernet. TCP, as we all know, is the protocol suite used by the internet, and it is a set of protocols. It's a group of protocols. It has all these protocols, many of them. We have already mentioned some of them. Okay. But you need to have some examples in the application layer. We have DNS, DHCP, SMTP, FTP. In transport, we have TCP, UDP, and so on. TCP/IP protocol suite. A web server here. This is a good example of communication. Here I have a web server encapsulating and sending a web page to a client. The client will de-encapsulate the web page for the web server. Encapsulate meaning like when you want to send a letter to someone, you will put it inside an envelope, right? And then you put from to. This is encapsulation, packaging. Okay. So we have encapsulating and de-encapsulation. So the advantages of open standard or standards is interoperability, meaning that they can communicate with each other. Competition, because they can compete with each other. Innovation, collaboration. Standards and organizations are vendor neutral, non-profit organizations established to develop and promote the concept of open standards. These organizations here, they are non-profit. They help us to manage these standards and manage the internet. All these non-profit organizations. IEEE, TIA, ITU, ICANN, all right? IANA. Do you know about the IANA? Have you ever registered a website? Anybody? To pay money to get a website or something? Then you will get some of this information. So open standards, for example, so these are the standards organizations involved within the development and support of TCP/IP. IANA here, they do the IP addresses, domain names, TCP, UDP, port numbers. They decide that, okay, HTTP is port 80, and so on. In the old days, if you are buying a system, this system is used for computer, for database or servers. Usually before, it was whatever you are buying, and the software and hardware, they are only working on only the products from the same company. It will not work with it's not compatible with other manufacturers. Okay, because they are using proprietary software and protocols. So they have more control. But you as a customer, you don't want that. You want to have the freedom. Okay, I might buy the hardware from you, but I'd like to buy the software from another place. Okay. So with the advancement of technologies, the widespread use of technology, networks have evolved, and there is a need for a communication to communicate with systems owned by other organizations. So we need to be able to communicate with systems from outside, from other organizations, other manufacturers. Now we talk about models providing standard protocols and services. This is the Open System Standard, or Open System Interconnection, OSI. Okay, and this is created by ISO. And we have the TCP/IP model. So these are the most common networking models. OSI model. The OSI model have 7 layers. Okay, each layer communicates to the layer next to it or adjacent to it. Okay, and the equivalent layer on the receiver. The top 3 layers, application, presentation, and session, are referred to the upper layers. The bottom 4 layers, transport, network, data link, and physical, these are the lower layers. Physical layer is the one connected to the cable. So these are the layers. Please have some time reading this. Take a minute, just look at them. And usually when we talk about layers, we start from 7 to 1. Okay, 7 to 1. Yes. Okay, but gradually you will be able to tell, okay, which one doing what. So the application layer contains protocol used for process-to-process communication. Okay. The presentation layer, it provides for common representation of the data, okay. The session layer provides service to the presentation layer to organize its dialogue and to manage data exchange. Dialogue is by session layer. Transport layer, it's dealing with segments, transfer and reassemble the data for individual communication. Network layer, it provides services to exchange the individual pieces of data over the network between identified end devices. The routing is happening in the network layer. Then we have the data link layer. This is dealing with your network interface card and physical address. Then we have the physical layer, layer number 1. The physical layer protocol describes the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connection for a bit transmission to and from a network device. This is the physical layer, which is at the end of your layers, the one that is directly connected to your media. Your media could be a cable or Wi-Fi. It's very important, especially if you are doing WAN also. OSI model. As the data goes through the OSI model on the sending device, it goes through a process called encapsulation. I have just mentioned, I explained to you encapsulation. Encapsulation is happening at the sender side or the transmitter. The receiver will do the opposite. It will de-encapsulate. It will open, like opening the envelope, removing the layers. Okay. So encapsulation is taking the data from the previous layer, adding a header, and sometimes header and trailer to it, and passing it to the next layer, where the process is repeated. What is this header or trailer? This is data being passed down to the next layer. When you add header, the header and the data is called PDU. Header or trailer, and the data is now becoming PDU. PDU stands for Protocol Data Unit. The receiver will strip the header and trailer and before passing the data up to the next layer. This process is called de-encapsulation. So this is the encapsulation and de-encapsulation. If you are coming from application, your PDU is called what? Data. You have to remember this also, please. Data. In the transport layer, your PDU is called segment. In the network layer, it's called packet. In the data link, it's called frames. In the physical, it's called bits. All right. This is the encapsulation stages. As you can see here, they are all adding headers, except the data link layer. It is adding header and trailer. Very important layer. Now we talk about the TCP/IP model. It is important for network engineers and administrators to understand the models, the components of this model. And nowadays TCP/IP is used on mostly all network devices. Even your smartphone, iPads, laptops, your security systems, CCTV systems, they use TCP/IP. Also, the TCP/IP model maps to the OSI model, so it's easier to understand. Why we do this? Because this will enrich our understanding of networks, protocols, and services. The TCP/IP has many similarities with the OSI. They both are layered approach. They both have layers. And each layer talks to the adjacent or to the peer layer on the other end. And they are both non-proprietary standards, so anyone can use. Most experts argue that the TCP/IP model is a truer reflection of how networking works. So TCP/IP is more practical, more easier to implement or to study, because it's very true reflection of how the network works. The TCP/IP has 4 layers. We said OSI have 7 layers. This one has 4 layers: application layer, transport layer, internet layer, and network layer. You see how we compare them? The first 3 layers in the OSI, here in the TCP/IP, combined to one layer called application. Then transport is transport. Network is now called internet in TCP/IP. Data link and physical, they are combined into network access layer. Any questions? What is segmenting for messages? We said that segments, they are in which layer? They are the PDU of which layer? Transport layer. Very good. Transport layer. Segmenting is the process of breaking up messages into smaller units. Multiplexing is the process of taking multiple streams of segmented data and interleaving them together. So I take several streams of segments and then send them together. Why? Because segmenting increases the speed. It increases efficiency. Because I am paying for my bandwidth, why don't I utilize it? Sequencing, it is the process of numbering the segments so that when they arrive at the destination, you can reassemble them. The TCP is responsible for the sequencing of these segments. Protocol data units, we already explained the encapsulation. With encapsulation, we said that at each layer, the PDU has a different name. We already mentioned for the application layer, it's called data. In transport layer, it is called segment. In internet layer, it's called packet, again. And in the network access layer, it is called frame, and then it is bits, okay? So the PDU passing down is taking 5 PDU names: data, segment, packet, frame, and bits, or bit stream. Local addressing. Identifying devices on a local network can be done using either host names, their MAC address, or physical address, or their NIC address, or their IP address. And they all should be unique within the LAN. Here they put for you some description of each layer in the TCP IP. You see here, the upper layers, they take care of encoding application data. The physical layer, it provides the timing and synchronization of bits. Host names. Host name is something easy for a human to read and remember. Okay? It's a method of identifying a device on the network. And usually it's configured by the system administrator. This could be the username or the department name and the number. Okay? For example, MX server for the Exchange server. These are some examples. DC1 for domain controller. It's not enough to only to use the host name. You need some IP address. You need some other identification like IP address to send information in the network. To find out your computer host name on your Windows, you can press Windows key and Control Run, or Windows key plus R. And then on the command line, type CMD and then type host name. It will type for you your computer name, your host name of your computer or your laptop. You can try this now, no problem. You can. Okay, IP addresses. So we said host names, they are human friendly, but they are not friendly for the computer. Computer, it needs more advanced technique in order to be able to communicate with local or remote networks. The host name is just local. So we need to reserve the host name to an IP address. An IP address is the network layer, layer 3. And in TCP IP, it is internet layer. Okay, or we call it logical address. They are all the same. It is used to deliver packets from source device to destination device. There is IP version 4 and there is IP version 6. IP version 4 is having 2 sections. Network part, or we call it prefix in IP version 6. It indicates the network group which the IP address is a member of. So each LAN should have the same network part. Then we have a host part, or interface ID in IP version 6. This identifies a specific device within the group and is unique for each device on the network. The MAC address is different thing. MAC address is in layer 2, okay, data link layer or network access layer. They call it physical address, hardware address, or BIA, burned in address, because you cannot change it. A MAC address is represented as 48 bits hexadecimal number. You can find the MAC address on your computer by typing the command ipconfig/all. We will do this in the lab. I'll show you how to find out the MAC address of your computer. Devices on a remote network. If the devices, they are on the same Ethernet network or in the same LAN, they will use the actual MAC address of the destination to communicate with the destination. So I will just put the MAC address of the destination. Okay. The MAC address is physically burned or embedded on your network card. And they are used for local addressing. The source MAC address will be that of the originator on the link. So the sender is the originator MAC address, and the destination also MAC address will be there in the frame. The destination MAC address will always be on the same link as the source, even if the ultimate destination is remote. So here we have one example. We have PC1 here communicating with PC1 on using the switch. They are in the same LAN. So you will find here that the destination will be the MAC address of user 2, this guy, and the source will be the MAC address of PC1. All right. For the network layer, addressing will be, the source will be the IP address of this PC1, the destination will be the IP address of this computer. You can see here the host 9. So this is all information is inserted in the header. For devices on a remote network, when the final destination is remote, you are using the IP address. Your layer 3 will provide layer 2 with the local default gateway IP address. Your router or your gateway, it will send it to the gateway, and then the gateway will send it to its path. Because it's not local, you have to go through the gateway, through the door. Understood? That's why you are using the gateway, because it is sent to a remote destination. And here we have the example. If the message is traveling from PC1 and it's going to the web server, then it will go through the gateway, and the gateway here is this interface of the router. All right. We will see now, watch the videos, and I will answer your